All right, we're going to go over the free response questions here on this Unit 7 and 8 review. This first question here is a really good question. It happened in 2018. And interestingly enough, when we were looking at the 2021 projections or the speculated hypothesis tests that StatsMedic put out, they thought this might be a good example of the type of problem that would show up this year in 2021 as the inference problem. So what happens is we first have this scenario, and it is an experiment. And so then we're asked basically, what are we able to infer from this experiment? It says, what can you conclude? What would a statistically significant result allow you to conclude? So what that's going for is the fact that this was an experiment. Yes, the design of this study uses random assignment to the two different procedures. And so that random assignment spreads unknown traits evenly. I always just like to throw that in there because that is the connection. That is why it's spreading unknown traits evenly um, of the patients to the treatment groups, so that the treatment is the main difference between the two treatments. So here is how you get credit on this. I went ahead and I copied and pasted the grading guidelines here. You get correct statement. If you said that yes, you can make a causal relationship. You can say it causes a reduction, justifies it based on random assignment of the patients to the procedures. Okay. All right, next. Then they ask you, does this provide convincing statistical evidence that those who receive, I've hidden it here because I had to put the grading guidelines there, but they gave a table of data. And so, again, that's hidden, but you have that on your original. And so, does that provide convincing statistical evidence that those who receive the new procedure have less recovery time from the surgery on average? See, we can't say for everybody individually, but overall, on average, than those who receive the standard procedure for patients similar to those in the study. So this is run a hypothesis test. That's what it is asking you to do. So you have got to understand the language of what it's asking, that you would then need to run a full hypothesis test. And that's the language. Does this provide statistical evidence of such and such? So I did a full phantoms. It looks like it's missing the M, but the M's right here. I was running out of room. So here's the parameters. We had two averages. These were two independent means. Mu, and I used the subscript S, was the average recovery time of all such patients who have the standard surgery procedure, and mu of N is the average recovery time of all such patients who have the new procedure. And the null hypothesis is that those are equal, but we alternatively were investigating. I did that the wrong way. I got to fix that. If the recovery time on the new is less than the standard, okay? And that I need to double check and make sure that I did my calculator here, math correct, and I'll go back and I'll check that here in a minute. But there was that. So that is what I should have circled. Maybe I did before I ran that two sample t-test. Okay. Conditions, let's talk about those. Random, independent, large enough, and then the approximately normal model applies. So random for both groups. It had stated random assignment of the 110 patients to the standard surgery and 100 patients to the new surgery. We had volunteers, but we stated random assignment. Independent. Okay, we don't need to do the 10% rule. Remember, this was something new that I have learned this year, is that only if there's random selection from you're randomly selecting from the population, okay? And so here we have volunteers. That doesn't meet that criteria. Random selection, and you're not replacing the subjects back into the random selection, okay? Only when you have that do you need to do that 10% condition. So I don't need to say 110 is less than 10% of, all patients on the standard surgery, okay? And 100 is less than 10% of all patients ever who could do the new surgery. It's kind of weird. So it doesn't make sense for experiments if you are not randomly selecting. All right, but it is important that here you say the patients in the standard surgery and the new surgery are independent of each other. That was key. All right, large enough? Yes, we are stating that both of these are greater than or equal to 30. So because of the central limit theorem, the approximately normal model applies. This is a two-sample t-test for independent, means you didn't have to write that word independent in there. Now, let me see if I had this information in. I just wanted to double check. I think this is the same data. I just wanted to double check and make sure I got my tail correct on that. So I'm going to go and run the two-sample t-test. And see here, I put my data in here. Yep, 217. The standard deviation was that, sample size, and so on. And yes, this was a greater than. Okay, good. So when I did compute that, I did get that greater than. Now, when you put your answer down, do not put e to the negative 12. And of course, 8.36 is not a probability. It's 8.36 times 10 to the negative 12. It is wrong if you use E for the notation. So notice I wrote this in scientific notation. To get credit for this phantoms, you don't have to put this calculator stuff, but you have to write out what this t-score is, what this p-value is, do scientific notation, or you wrote it out with all the 11 zeros. And then you must include the DFT, T, not Z. Remember, with degrees of freedom or t-test, you must include the DF. So this p-value is approximately 0. It's not exactly 0. It's approximately 0, and that's less than alpha. So we reject HO. Since the p-value is less than alpha, I reject HO. There is evidence that, and then from here on out, I just copied it. I just reworded it from exactly what they wrote. There is evidence that those who receive the new procedure will have less recovery time from the surgery on average than those who receive the standard procedure for patients similar to those in the study. So I just regurgitated specifically what they were asking. All right, that was free response. First question in here. I'm going to skip over all of the multiple choices and do that in a separate video. But then we get to this problem here, number 27. So with number 27, 2015, not too long ago, question number 2. So we have information, we have a interval here that we've been given. So they give us this is the sample proportion plus or minus 0.06. So that's your margin of error, 0.06. Because remember that with this confidence interval, this is your statistic, which in this case is a proportion, plus or minus the critical value, and then times that standard deviation, whatever that is. For proportions, it's that. Okay. So that's what all that is. I went ahead and I had kind of written myself a note that that's going from 0.09 because I subtracted 0.06 to 0.21 because I added 0.06. So does this confidence interval provide convincing statistical evidence that the program is not working? Well, they wanted the program to give P represents the proportion of bills that receive a discount. And they wanted that in the long run. They wanted it to be 20%. So the claim it should be 20%, but we're wondering, is it not equal to that? Well, look at my interval. That 20% is in the interval. And so therefore 20% is plausible. I'm not saying it is it. I'm just saying it's a possibility. So essentially correct if it states that because the interval contains 0.20, it does not provide convincing statistical evidence that it is not working. Now, next, does this interval provide convincing statistical evidence that the program generated the discount with a probability of 0.2? So it's basically saying, does it mean it is 0.2? And that's no. That's like saying the null hypothesis is true, which we can never say. So the interval is just an estimate from 0.09 to 0.21. It's a plausible range. The true proportion can be anywhere in there. I cannot say, bam, it is 20%. It's just somewhere in there. And so the response concludes that there is not convincing evidence that the discount with probability of 0.20 and justifies this by noting that there are values other than 0.20 in the interval. Okay? All right. Now, specifically, they say they are going to make a sample, take a sample now 4 times the original sample size. So, do you remember this? And it was in the notes. I don't remember exactly what page in the notes it was on, but I showed this specifically. Here we have the margin of error equaling, so what's in red here is what's there, z star times that standard deviation. Well, make n 4 times as big, so I put times 4 here. Well, that's the square root of 1 over 4. Well, what's the square root of 1 over 4? To make this equal on the left side, that's 1/2. If I had put 9 in there, on the left I'd put 1/3. If I put 16 in there, on the left I'd put 1/4. So then that means increasing the sample size by 4 times will make the margin of error half its previous size. So it won't be 0.06 anymore. The margin of error will be 0.03. So that makes the new interval 0.12 to 0.18. So to get credit for there, it's essentially correct if the response gives the correct value of 0.03 as the new margin of error by using the correct formula or providing a correct explanation that recognizes quadrupling the sample size divides the margin of error by 2. So they wanted this explanation, whether it's in words or showing by formula, and then that new margin of error was 0.03. So then the last question, based on that margin of error, this 0.03, so would you conclude that the program is working as intended? And so then that is, the new interval does not include 0.20. Therefore, that would appear that there is evidence that the program is not working. Now, look at these notes. If you did a wrong margin of error here in part B, you would be marked off for part B. But if you used it correctly in your statement with part C, you would get credit for part C, even though you missed part B. So if you did not give a specific margin of error in part B, but the response provides a complete correct conclusion referencing a smaller margin of error, would then maybe not include it. Maybe you just say, not sure what the margin of error is, but I do know it'd be smaller. So that therefore, if it does not include 0.20, then the program is not working. All right, then you could get credit for C. That's the next free response. Next, 2018 or 2012, free response 28. We actually have seen this question. We did this one back when we were doing errors. So I'm going to go through it pretty quickly and just let you kind of read through this. For part A, you had to describe the error in context. It's about there really is less than 35% of adults living in the city, but our sample doesn't give us evidence, or we think it's still 35%. And describe a consequence. To get full credit, you had to say something like not funding the program or then continuing poor physical fitness for the adults in the city. B says they recruit 185 volunteers. They got this p-value. So to get credit here, what would they conclude? Since the p-value of 0.97 is greater than alpha, we would fail to reject. There is not evidence that the proportion of adults in the city is less that proportion of adults in the city who pass the physical fitness test, I forgot that little bit, is less than 35%. Okay, you had to make that connection to that. To get full credit here, you had to link the p-value to being greater than alpha. or state that the p-value is large. And then use context referring to the proportion of adults who are able to pass the physical fitness test. See, so I would need to put that in there. And then says there is lack of evidence for the HA. All right, and finally, primary flaw. This is the part that I think would really get people marked down, because I think this does a poor job in the question of what the rubric requires. I don't think that they fully asked this question. I just knew to answer these things because I know this is a typical line of thinking of what they ask. But look here, they said describe the primary flaw and explain why it is a concern. Okay, so first, the flaw. It was volunteers. Okay, so then explain why it's a concern. So then naturally you're going to say, I think that the adults who feel more comfortable participating in physical fitness would be the adults who would be coming and volunteering for the test. Okay, but in fact, so look at the grading guidelines here. Number 1, states the sample is not random or says it's volunteers. Okay, good, did that. Number 2, describes how the sample is different with regards to the physical fitness. So we see, I did that. Part 2, I said these adults like physical fitness better, so they're probably more physically fit people. But this is the part it doesn't specifically ask for, and I bet person after person after person missed this part and got marked down to a P instead of essentially correct for this component. It says addresses the idea of making an inference from a sample by stating that the sample overestimates the population. And I wrote that here. Therefore, the proportion of adults obtained in the sample is most likely overestimating the true proportion of adults who would pass the physical fitness test. Okay. And I just knew to include that. I don't think that that's naturally something that it said there. But they're always looking for how is this flaw impacting your inference that you can make about the population. The sample isn't representative. It's going to overestimate what really is happening in the population. Okay. So they wanted that for full credit there. And our last one. Here we have 2 statements. They did say, assume the conditions for inference have been met. So they wanted a panic without the assumptions. Yay. So it's P is the proportion of all adults who chose the economy, adults in the U.S. who chose the economy statement. It's a 1 proportion. See, so let's actually look at how you got credit. Section 1 that they checked was that you state the correct procedure by name or formula. So that's this. And calculate the confidence interval. So that's this. So to get part 1 correct, you did these 2 things here. All right. Now, next, essentially correct. The next section, section 2, checked this. Estimates a proportion. The essentially correct, if it includes these 4, it estimates a proportion. Okay, we did that. Infers about the population, states 90. So this is all about the conclusion. Interesting. That never did they say defined the parameter. It's interesting. Okay, but here we go. So I am 95% confident that the true proportion, I'm estimating the true proportion of all adults in the U.S. who would have chosen the economy statement, and then I'm 95% confident I did that, is between this percent and this percent. All right, so I would have gotten those 2 full ones. Now, here's this next one. Parts B and C counted together as 1 component, okay? So to get full credit, and I'm a little concerned that we may not have gotten full credit on B. To get full credit on part B, you would have needed to talk about how. In order, you had to say, look, in part B, you had to say something about the sampling distribution for the p hats is approximately normal. Okay, so that's what I did. I would have said this. In order for the sampling distribution, because that's what we're making, is the sampling distribution of all the p hats to be approximately normal, then we would need to have at least 10 successes and at least 10 failures. So if you don't have that, notes referring to the sampling distribution needing to be normal without explicitly stating p hat satisfies component 1. So if you didn't specifically say p hat, but they wanted sampling distribute in order to make the sampling distribution approximately normal was required. Okay? All right, and then part C is saying, why could this not be? Why is this a 1 proportion z-test, not a 2 proportion z-test? Well, that is because this was made from 1 sample of adults. So you cannot run a 2 proportion test, a proportion about this and a proportion about this, because those are from the same 1 sample, not 2 independent samples. So that's what you had to say here. You cannot run a test for 2 independent samples because these results came from 1 sample of U.S. adults instead of 2 separate independent samples. And that's what had to be stated to get your full credit on that. Okay, there's the free responses. And just making sure that you kind of like are following the train of thought of the things that you need to include to get all those little full credits to get an E instead of a P on these correct. All right, so good luck to you, and you can go and watch the multiple choice video or follow along with the answer key for that.